Now we're going to add two vectors using their components. So I have a couple of vectors here ready to go that we're going to add together. This gives them names. See, I used E on the last one, EF. How about F and G, just to give them names. So here's F and G, and I'm trying to find F plus G. I've already laid them tip to tail because I'm going to show you that what we're about to do works. So if I visually was looking at this, I know that the result of this, F plus G, would be a vector from the beginning to the end, so like that. Okay, that is the resultant right there. Okay, now it does make a triangle, but it's not a right triangle, so I can't like use the Pythagorean theorem to figure it out. If I knew some angles, I might be able to use the law of sines or the law of cosines, and I told you in class, I do not want you doing that. Please do not do that, okay? Now, to do adding by components, I do need some angles. I'm not going to draw them right now, but I will when I'm done, okay? First, I just want to conceptually show you vaguely what we're going to do. So the idea is that I know that there's a resultant over here. My goal is to find the x and y components of the resultant. So I am looking for, say, make a little right triangle here. I am looking for Rx and Ry right here. That is what I'm looking for. I forgot the vector signs. Ry. If I could find Rx and Ry, I would have this red right triangle, and it would be very easy to find R, the magnitude of R. I could even find the angle of R. I'll put that in 2. Like I could find what angle that is. All I need are these legs, Rx and Ry. So here's how we get them. We are going to break the other vectors up into their components. So F would look like this. X would be here. Okay. I'm going to use a different color for Y. Fy would be here. Okay. Note the nice right angle right there. Okay. Now to actually get those, I would need to know this, like n angle, so maybe this one. I would need to know that. Okay. But I could get them if I knew that. And then I'm going to break up the G into, this one's easier to draw Y first, but you don't have to. Here's GY. I also could have done X this way first and then G, but I don't know, it was easier for me to do Y for me. Okay, and here's GX. Sorry, that's not quite straight. Pretend it's straight. Okay. GX. Okay. And if I had any angles, I could figure out this is its own little, you guys see the G triangle apparently, like the G triangle, I could find GY and GX if I knew any angles at all in there. And I have the F triangle, I could find FX and FY if I knew any angles in there. So these are very gettable, right? We could find them using sines and cosines. Once I have them, if you trace them around, so let's say I start here, if I follow just the x's, for instance, follow x, well, fx takes me 2, 4, 6, it takes me 7 squares to the right. And then if I were to add to that gx, well, gx takes me 2, 4, 6, 8, 9 to the left. Okay, so if I did fx, oh, that should be green, fx plus gx, okay, fx plus gx, where I'm adding the vectors. So fx is like positive 7, gx is negative 9. If I add those, what I get is the same as rx. Rx is 2 to the left. So I have 7 to the right plus 9 to the left would give me a total of 2 to the left. That is how I'm going to get Rx. Okay. if I can just find the x components of f and g and add them together, and these can just be added together because they're in the same dimension. If they're in the same dimension, I just have to pay attention to like negatives and positives, but that's it. That's all I have to pay attention to. Okay, so this is very gettable. Fx is very gettable, Fg is very gettable, and Fx plus Gx is also extremely, like, I can get that. It's very gettable. Okay, same thing with y. If you watch y, if I follow it around, Fy is 1, 2, 3, it's 4 squares up. Gy is 2 squares up, so maybe I'd call that positive 4 and positive 2, so I get positive 6. If I go look at Ry, it is in fact 2, 4, it is 6 squares up. It is positive 6. So this does in fact, the Ry equals the sum of, of Fy and Gy. Okay, so the idea behind adding by components is I take any vectors that I have that are at angles. I use the idea of components and some trigonometry to find their components. Then I add together just the x's to get a total x and just the y's to get a total y. And then I will have made this red triangle where I've got the two legs. I can then find the magnitude of r would be doing the Pythagorean theorem with those two legs. So it would look like this. Okay. And the angle that it would make, I would need to do some inverse trig to find like whatever angle it was. If it's the one that I've marked in red, then it would be inverse tangent of opposite over adjacent, which would look like that. And just like in the last video about components, I'd need to be careful about this will just get me one angle. I have to decide what quadrants it's in and stuff. But this will get me answers. That will get me the magnitude of the answer. Now it is a bit tedious. You have to break down my two vectors, break them down to their pieces, rearrange their pieces, put the pieces back together. It's a bit annoying, but it works, and it works every time, and it works with as many vectors as you want. I only added 2 vectors here, but I could add hundreds if I wanted to. I just would need to find the x and y components of each of those 100 vectors, and then my Rx would be the sum of the x components of each of the 100 vectors, and my Ry would be the y components added together, and so on and so forth. Now, a side note here, I just want to add right at the end, you can only do this if your vectors are representing the same type of quantity. Okay, so like I just did generic vectors FG, but usually in physics these are representing vector quantities. Like maybe they're both velocities. I could do this if they're both velocities. I could do this if they're both displacements. I could do this if they're both forces, but they have to be the same type of quantity. Okay, you can only add vectors if they represent the same type of quantity. So don't go adding a velocity to an acceleration. You cannot do that. Quantity. Don't add forces to accelerations. I see that one a lot. Quantity. Okay. Also very common. I see a lot of people trying to add velocities to displacements. You can't do that. They have to be the same type of quantity or this won't work.